We've done simplifying rational expressions, multiplying them, dividing them, adding, subtracting. It's a lot to keep straight. This video is just to review it all, point out little tricks along the way. I'm going to do the problems with fast forward. That way you're able to just say, can I do that? Can't I do that? Where do I need to pause? We'll try to keep the video nice and short. This is an adding problem. When I add and subtract fractions or rational expressions, I need a common denominator. I make a common denominator by looking what's in one and not in the other. So in this case, there's an x minus 1 in the second denominator, so I better put it in the first denominator. There's an x plus 2 in the first denominator, so I better put it in the second denominator. And I end up with this problem. It looks the same. There's just a little trick I want to point out. My first step, if it's a subtracting problem, my first step is I need a common denominator. So I go to make my common denominator. One move I might do is I might put this 2 here, right? And I'm trying to make the denominators match, and I need this 2. But I don't really need to do that because I could right off the bat say, oh, I have a 4 over 2. If I factor a 2 out of both and cancel it, this becomes 2 over 1, and I don't really need to write 1. Then all I need to do to make my common denominator is put the x plus 3 here. By factoring that 2 first, I don't need to make my problem more complicated. It ends up a simpler thing. So if I notice that my fractions simplify before I combine them, I should simplify them first. This problem, in fast forward, ends up negative x minus 2 over x minus 3, x plus 3. If the numerator factored, I would make sure to factor the numerator so I could see if something cancels, but nothing cancels. Nothing factors out of that, so nothing cancels. This problem is different. Why is this problem different? Because it's division. Don't get confused. Don't be like, oh, I need to make common denominator. I need to make multiplication, division. You don't need a common denominator, right? The way we did it is we factored both the numerator and denominator as much as we could. Then we did some keep, change, flip. And we cancel the common factors. Remember that when we're doing multiplying and we don't see a fraction, you can always make a fraction by putting over 1. This one, the trickiest bit is just being able to factor out this. So when I go to factor this, 2x minus 3, 2x minus 1, and the other denominator factor is pretty straightforward. I can take a 6 out. That's my GCF. This is a subtraction problem, so I'm doing this all because my goal is to have a common denominator. I need a 2x minus 1 in this one. And then I have a 2 here. I have a 6 here. Rather than multiply this one by 2 and this one by 6, that I could do. It would just be a little excessive. Instead, what I'm going to do is I'm just going to do times 3 here. That way I have a 6 and a 6. The rest of the problem goes like... ta-da! If the top factored, I would factor the top just to check if something cancels, but the top does not factor. Remember, because we've done so much, it's easy to forget these things. Remember, if you have fractions inside fractions, you just need to look for the big fraction bar. The big fraction bar is your division symbol. This problem is just written in another way. This numerator divided by x squared plus 3x minus 18. Everything above the orange big bar divided by everything below the big bar. This doesn't look like a fraction, but I can make it a fraction. So this problem becomes x plus 6 over 4x times 1 over x squared plus 3x minus 18. And then I continue like I normally do my multiplication of rational expressions. Here I have the whole numerator ends up canceling out, so what that leaves behind is just 1. 4x times x minus 3 on the bottom. Again, if I don't see a denominator, I can always make a denominator. This problem is particularly easy because everything is already as factored as it could be. I'm just rewriting the problem. There's no factoring I can do on either thing. So I know I just need to put a x squared plus 5 in this one. And I end up with this problem. We haven't seen one like before, but everything we know in math can lead us to how to do it. We have a minus and we have a division. Order of operation says take care of the division problem first. Right, to complete the division problem, I do keep change flip, so x over 5 times 15x plus 5 over x cubed minus 4x. Then I complete the multiplication problem by factoring that second denominator. I can factor out a GCF of x. And then I can actually further factor that second denominator by taking advantage of difference of squares, x minus 1 times x plus 1. Once it's all factored, I multiply everything together and I cancel out my common factors. I have a 5 in common and I have an x in common. Once I have this purple one all the way simplified, then I can begin doing the subtraction problem. Which doesn't look fun. Oh, you know what? It doesn't look fun because I messed up way up here. X cubed minus 4x. When I take out an x, I'm left with x squared minus 4. So difference of squares says that's going to turn into x times x minus 2, x plus 2. I still have an x minus 2, x plus 2, x minus 2, x plus 2. Now I'm a little bit more ready because now I can see, okay, I don't have a common denominator, but at least I don't need to do too much. I just need to put a x plus 2 into this first fraction. Now they both have the same common denominator. My problem is going to finish. Now let's review problems like this. Problems that say, state the excluded values. The simplify part of this problem, then simplify this. That I think we're probably going to be pretty good with. It's the state the excluded values part that we maybe haven't seen in a week, so we should just have it at the front of our brains. The way I do this is I factor everything as much as I can. Factor the numerator, factor the denominator as much as I can, because that's how I simplify it. Is I factor and hope things cancel. In this case, it factors on bottom, nothing really factors on top. Before I cancel anything, once everything is all the way factored but nothing is yet canceled, that's when I do state the excluded values. State the excluded values comes from what are the zeros of the denominator. The zeros of my denominator are 5 and -5. Those are my excluded values. Those are the numbers that when plugged in would make 5 over 0, which is an impossible math problem. So I have to exclude them. I have to say those are not allowed to be x values. They are excluded from the domain. Simplifying is then just a matter of canceling out anything that cancels. In this case, nothing cancels. This is a trick question. You wouldn't do it. But what people not as good at math would do is they'd be like, oh, this 5 cancels with this 5. But that's not how it works. You can only cancel whole factors at a time. If there were an x plus 5 on top, I could cancel that. So for this one, simplify. There's nothing to simplify. You can write this. If you wrote this, it would also be correct. State the excluded values, then simplify. So again, I'm just going to need to factor everything as much as I can. I could factor 3 out of the numerator. My denominator is going to factor to x minus 1, x minus 3. And then before I cancel anything, I state the excluded values. The excluded values are the zeros of my denominator, 1 and 3. These are the numbers that I exclude from my domain. That I say x could be anything except I'm excluding 1 and 3. X cannot be those. If I plug them in, I'm going to get something divided by 0. Once I have that, I can move on to simplifying. Simplifying comes from canceling common factors and just writing down what is left. One more. State the excluded values, then simplify. Okay, so again, I'm going to factor as much as I can. That numerator, factor that. It seems like maybe I'll go to the side of my paper. 4x squared minus 4x minus 32x plus 32. That's a weird problem. Right? I could factor. If I did grouping now, it would work, but why don't I just simplify by combining like terms first? Then I'll worry about actually factoring it. So now I know my numerator factors to 4 times x minus 8 times x minus 1. My denominator, maybe I also want to go to the side of my paper and figure out what that is. 2x squared plus 8x minus 10. I could take a GCF out. And then I have to think about what multiplies to -5 and adds to +4. So I have 2. X plus 5, x minus 1. Now I go ahead and I think about what my excluded values are once everything's factored, but before I cancel, I do excluded values. My excluded values are 1, -5, and that 2 doesn't give me any value. Right? If I'm looking for zeros, I'm thinking, okay, what makes x minus 1 0? Oh, x equals 1 does. What makes x plus 5 0? Oh, that happens when x is -5. What makes 2 0? That's impossible. This doesn't give me, there's no zeros. 2 doesn't introduce any possibility of my denominator coming out to 0. My only zeros are -5 and 1. Those are my excluded values. When I do simplify, I just cancel my common factors. X minus 1 cancels. 4 over 2 is the same as 2 over 1, and I don't really need to write a 1. So that turns into 2 times x minus 8 over x plus 5.